parabola. So parabola is parabola. Actually, parabola is the most important one. Another y is equals to ax squared plus bx plus c. Okay. You change your pen. So until is to sketch the graph. Sketching the graph is very easy. For example, let's say we have y is equals to minus 2x squared plus 2x plus 12. Then we want to sketch the graph. So increasing for Yamatom, you have to determine the value of a. Again, so shape. So we like a shape, we like the value of a. Again, color a is negative. Okay, if a is negative, you will concave down. Okay, that's the value of a. And after getting the value of a, we get the value of what? After getting the value of a, we get the value of what again? The turning point. The turning point, x is equals to minus b over x is equals to minus b over 2a. Bear in mind, or this equation is also equation. That's how we get the equation of axis of symmetry. By one.
For parabola.
Yeah, axis of symmetry means it's the line that cuts the graph into two equal parts. This is the equation of axis of symmetry is also the x value. The x value of the turning point. Okay. So robaling x is equals to minus, what is our b here? B here na 2 divided by 2 multiplied by 1 minus 2. Therefore x here na 1 over 2. Then wanyaka y ra substitute mo. Kinale minus kinale substitute that 1 over 2. So kobale y is equals to minus 2 1 over 2 all squared again plus 2 multiplied by 1 over 2 plus 12. Then we get how much?
2 plus 2 plus 3.
Right. 25 over
12. 12 plus 4. 2. 12 plus 4 where? Negative 2 plus
negative 2 1 over 2.
12. What's it 12? What's it 12? Yeah, get who you to 1 over 4.
You got 12.
Yeah, negative 12. Because when you take it about you 1.
25 over 2. 25 over 2. 25 over 2. Is recorded. 25 over 2. So you have x value like 1 over 2 and 25 over 2. Okay. Turning point again. Then from turning point we find the intercepts. Intercepts. X intercept. Right, or x intercept y is equals to 0. Yeah. So value 0 is equals to minus 2x squared plus 2x plus 12. is the same as x squared again minus x minus 12 is equals to 0 again. So rogaling factorize equals to 0 rogaling x
Four letter
so give 4 letter give you a minus
minus 4 plus 3.
so x basically is equals to 3 or
It can be minus minus.
so we keep plus again minus
3.
3 x is equals to 4 then ranyaka the y-intercept where x is equals to 0 basically the y-intercept one y is equals to 12 so now 0 and 12 again nearly 0 and 12 so when I reach 0 and 12 so then we can sketch the graph. I can rub here, I can rub here. So now we can sketch the graph. We can sketch the graph. So sketch the graph. You just need your Cartesian plane like this. You just need your Cartesian plane like this. You just put your x-intercept in a minus 3. Minus 3 and 4. So mokiki minus 3 and 0. Mokinale 4 and 0. Then the turning point. 1 over 2 and what? 25 over 2. You just have to estimate it. Therefore the graph will be like this. So with these three, just these three of them, you can sketch the graph. Remember? Yeah? Then you will over the intercept tomorrow. Parking 0 and 12. Then your graph is sketched. Remember? Then this one is that line here. More we have that line here. So that line, remember? Isosymmetry. It cuts the graph into two equal parts. Remember? Because this distance from here to here must be equal. Remember? The axis of symmetry, the equation of the axis of symmetry of the graph. Then we have another thing here. So we can sketch another graph here. Highly in this form. It's either Wolfilion in this form or Wolfilion in this form. Or Wolfilion in this form. Or Wolfilion in this form. Let me do another page. Or Wolfilion in this form. So Wolfilion in this form. Let's say Wolfilion
minus p over 2.
Example number 2. Let's say you want to sketch the following. So if you want to sketch the following, let's say I'm given y is equals to x plus 1 all squared plus 2. Then I want to sketch. Right, or the first thing that we do is to get the shape. Therefore, a is greater than 0. Color is concave what? Up. Then number 2, we get the turning point. So the coordinates of the turning point are negative 1 and 2. We already have them. So robaling mo. Then number 3, robata x, robata intercepts. Okay?
Yeah.
So robata x intercept where y is equals to 0. So robaling 0 is equals to x plus 1 all squared plus 2. But the effect of taking minus 2 to this side is equals to x plus 1. You'll find no solution.
because this one is a negative.
How we square up both sides, you find a solution. But you can expand it. Okay, wanna put how can expand that? Well, there is a quadratic formula.
Yeah.
Still, you find a solution. Just that nage winning a pay cause once x is equals to 0, intersect. So y is equals to what? 0 plus 1 whole squared plus 2, which is going to be what? 3. Probably 0 and 3. Then with just this, we can sketch the graph. With just this, we can sketch the graph. So, only minus 1 and 2 somewhere here. Yeah. So, our graph is where minus 1 and 2. And here we have 0 and 3. So, this is our graph. Yeah. This is our graph. This is our graph. So, ntho e botlhokwa tse tshwanetse re tlhaloganye. Ntho e botlhokwa e tshwanetse re tlhaloganye ke gore when we are given the equation like this, let's say for example y is equals to x plus 1 whole squared plus 2. We can be able to transpose to take the equation from axy minus p whole squared plus q, then raise to this y is equals to a. We must be able to know how to take this one to this form. Y is equals to ax squared plus bx plus c. Agora ito rahile mo sa the values of the turning point, which is p and q. Okay? So more barfile. So we want to take this one from here, it is from here. Whatever. So read. So we say a from here to here. What are we going to do? Expand. Whatever. So about y is equals to what?
X plus 1.
X plus 1.
X plus 1.
X plus 1 plus what?
2.
Plus 2. Then robaling
X squared.
Probably x squared plus what?
2x.
2x plus 1 plus 2. Yeah, baby. Then go to robali y is equals to x squared plus what?
2x.
Plus 2x plus 3. It's in the form. Yeah. Since Rekonotsia A is from there to there, we must also know how to take this one from here. We must also know how to take this one from here to here. Yeah. Right, or when you take it from here to there, we complete the square. Yeah. So how now y is equals to x squared plus 2x plus 3. When you use a back, whatever. Here we set a back, you're going to find the most important thing. You can find the x intercept there, the x value of the turning point minus b over 2a. You okay? Minus b 2 over 2 multiplied by a. So info
Negative 1.
Negative 1. Remember? Therefore, I got a y of negative 1. So you have negative 1 whole squared plus 2 multiplied by negative 1 plus 3. You have
6.
Oh, that's 6.
6. Oh, negative 1.
Alpha 3. Alpha 2.
Negative 1 ke 1.
Ke 1 e.
Yeah,
1
ke a
plus
bona.
minus 2. Wa bona re fa 2
Yeah,
akere.
2
So coral coordinates tsa di-turning point ke eng?
minus 1 and 2.
Minus 1 and 2. Then we substitute them in this equation. Okay? Y is equals to ax minus p squared plus q. Weba? Therefore a ya ke bokae mo? Ke 1 mo weba? X ke kry-ile bokae mo? Minus 1.
Minus 1
So go ra mo bang plus 1.
plus 1.
Q ya ke kry-ile bokae?
Really
2.
2.
Weba?
Okay.
Ntho e botlhokwa tshwanetse o itse gore these ones are your turning points. X values of the turning points. Weba? So we know how to take this one from here to here, and this one from here to here. Over. So then now, how le ka mokgwa ko ra reng we can move to the next thing. The next thing is to determine the equation. We use this equation y is equals to a x minus r1 x minus r2, or number 2 where you have y is equals to a x minus p all squared plus q. When do we use when, where? Where do we use when, where? We use this one when we are given what? We use this one when we are given the roots or x-intercept. And we use this one when we are given what?
Turning point.
Turning point, or we can say stationary points. Okay. So we can say, okay, example. Let's say we have the following graph. We have minus 1, we have 3, we have minus 2. Which equation are we going to use?
Equation 1. We're going to use equation 1.
Equation 1. Why?
Because we have the x-intercept.
We're given the x-intercept. Square root of this equation that y is equals to a x minus r1 x minus r2 or x2. Okay. So let's substitute that the x-intercept the pay. Probably over x plus 1. I get x minus what? 3. Therefore you have okay. Then I can substitute any other point, which is this one. Right? So probably over y I think minus 2 is equals to over 0. Right? This times this is like a minus 3a minus 2a. Therefore a give away 2 over 3. Or my graph is going to be y is equals to 2 over 3 x plus 1 x minus 3. Remember? Because this one a. I substitute that a key. Again. Therefore my final equation will be y is equals to 2 over 3 I will for a limo x squared minus 2x. Again.
Minus 3.
Minus 3. Therefore final is going to be what? 2 over 3 x squared minus what? 4 over 3x minus 2. So this is my final equation.
So leaving it like this. Okay, one shot and mark.
Are we can't do it really like this? Standard forms. So it's either equation is either with letter like this or like right what?
Yeah, that's right.
So it's either with letter like this or with letter in that other form. yabo. Yabo. Tama picture. Yabo. Ke lo tse re nang le tsona ntate. Or if you can be given another one. So this one covers which one? If you want to determine the equation.
Equation 2.
Huh?
The second equation.
The second one again. So covering y is equals to ax minus p.
Squared plus q.
So I have my values of p and q again. So over a p by x minus what?
1
Squared plus 2. Then I have to get my value of a again. I substitute this other point. So for y I think 2 is equals to a. X at over 6 minus 1 all squared plus 2. Kuvale minus 4 is equals to 25a. Okay? Divide by 25. Divide by 25. Okay?
2 over 5.
So finally over y is equals to minus 4 over 25 x minus 1 all squared plus 2. Yabo. Yoba kamkhulu determining the equation. Then essence and really more we can discuss the domain and range. We can discuss the domain and range. So the domain
excellent real number.
Of course it's defined everywhere. Yabo. For any value of x that I'm going to substitute here, it's there on the graph. Yabo. It's there on the graph until positive infinity. For value of x that I'm going to substitute is there up until what? Negative infinity. That's why I get x is an element of R. Yabo. Then we also have the range. So range over y is an element of R, but y is greater than q, or we have y is an element of R, or y is less than q. A key greater than q when it's like this. Q is the y value, I get. Then less than q when it's like this. Well, so for this one matches this one. Okay. So if it matches this one, the range here thing you okay. What will be the range? The range of this graph is going to be what? Over y element of R, y 2 pellets. Y is less than 2. That's the domain and range. If no, you can berekisa le. How you berekisa monor y is an element of e thoma from 2 going down again,
Mm.
from minus infinity, round bracket, then 2 is included,
Included.
square bracket. Can use it
Yeah, kind of. E bereka mo.
more.
And then only something like this. That wait.
Yeah, so ke di kenyo tsa di or and yeah. So we discussed the domain and range. Ushata the nature of roots. So the nature of roots.